All right, we're going to take a look now at some of the examples that go along with this idea of a p-series. So take a look here at example number 2. This is a super simple example. Determine whether the following series converges or diverges. All right, so at its face, this may seem slightly difficult because I'm not given my series notation in the same way that I have in many of the problems that we've previously seen. But here I might be able to quickly determine a way that I can rewrite or re-express this series. So I'll say this. We can express the series as 1 over n to the 1/3 power. You might be able to kind of see that, right? Like I have 1 over cube root of 1, 1 over cube root of 2, 1 over cube root of 3, so on and so forth. But by writing it in this way, I can see this is a p-series. Specifically with p equal to the value of 1/3. And if I look at what I have in the box above, I can see that very clearly 1/3 is less than 1, and therefore this series diverges. Boom, got it, nailed it. Right? So this argument here is unbelievably short if I can recognize again that it's a specific kind of series. And that is generally kind of a theme. When we take a look at all of the different types of series that we have really quick and easy conclusions for those kinds of series. It's when we go to the tests that things start to get a little more long and drawn out. So I'm going to go ahead and take a look here then at example number 3. Now this is one that I'm going to ask you to try. So at this point, I would ask you to kind of read this, pause the video, and try to see if you could answer it yourself. Could you come up with a way to use the ideas that we've talked about, not just in this section, but in all sections thus far, to see if you could attempt to answer this question? And if so, try to write out your answer very nicely, and then you can resume the video and see my solution. I'll pause here briefly for a moment just to give you time to pause the video yourself. Okay, so here's going to be my solution. I'll start with this. I'll say, we note that this series could be rewritten slightly. So I could notice that first it could be re-expressed as like a 9/2 and a 1 over a k to the 3/2. This seems to be totally doable. But I can also remember from before that I can always take a constant and pull it outside of a series. We talked about that in the last section. So if I can do this, then what I can see is that I'm left with a series that's a 1 over k to a power. So I can say that this series is a p-series with p equaling 3/2, which is bigger than 1. And so it converges. That may seem like I'm done at that point, but I'm not quite done, because the question wasn't, does this series converge? The question was, does the original series converge? But then very, very clearly, like we had said in previous sections, if I take something convergent and I multiply it by a number, I don't change convergence. So I'll say, therefore, this series is also convergent. You'll see here this section is very, very short, and I'm going to, again, really highly encourage you, practice these ideas as much as you can in the worksheets, because worksheet problems always feel slightly different than the ones that we do in class, just because, well, they're different problems. But try those out, and of course, as you come across any questions, please, by all means, let me know. All right, that concludes 5.3.3. Next time we'll start in 5.4.